look at how to do some operations with complex numbers. First of all, let's review what is a complex number. And I do have a definition here. A complex number is written in the form a plus bi, where a and b are numbers, so they can be negative, they can be positive. But the one with the I is an imaginary number, and the one with no I is the real number. So you have a real and imaginary. A pure imaginary number is written in the form bi, so number with an I is just called a pure imaginary number. We are going to do a few examples here on different operations. First of all, let's go ahead and review how to raise I to a power. When you have I to a specific power, all you're going to do is take the exponent, you're going to divide it by 4, and you are going to use the following values that you see on the screen. The number that you're looking for, when you divide by 4, and this is using long division, you are going to look at the remainder, and depending on the remainder is going to be the value that you're going to use for the I. Notice that when you look at the remainders, we have only 4 of them, 0 all the way to 3. These are actually the exponents for the i's I'm giving you guys. We have an imaginary one here, we have a 2, and we have a 3. So we're going to use either a positive one. For this value here, the square root of negative 1, you don't have to write it down this way. If you have a remainder of 1, all you have to do is put I for your answer. Even though the definition for I is here, I is sufficient. When you have an I to the second power, remainder of 2, the answer is negative 1, and I to the third is negative I. So let's try a couple of examples here. We have 2 i's, and the first I has an exponent of 83. So I want to know what value that is. So I'm going to take the exponent and I'm going to write it down here. I'm going to divide it by 4, which is what you always divide by, 4. And you do the long division process. 4 goes into 8 2 times. You multiply the numbers. 4 times 2 is 8. You subtract the numbers. That's 0. You bring down the next number. 4 does not go into 3. 0. Now we don't want decimals. You can put a decimal and add a 0 and do that. But what we're looking for is the remainder. So since 4 does not go into 3, this number here is your remainder. Let me put an R for remainder. So we are looking at the value of I to the third power. I to the third. That's what we're looking for. So let me go back. And I to the third power is negative I. So your answer for this I raised to that power is negative I. Let me just double check here. I to the third, negative I. Now for the next one, we have negative 6. We have a number in front of the I to the 17th power. First, keep the number negative. If it's positive, keep it positive. So I'm going to write down negative 6 here. I'm going to simplify what this is. So I want to know what value this I has. So I'm going to take the exponents divided by 4. So 4 goes into 17, 4 times 4 is 16, subtract the numbers, and that's going to be 1. 4 doesn't go into 1, so basically this number here is your remainder. And this is the same thing as I to the first. Now remember that this 1 can be imaginary, since it's a 1, so we have this value. But we don't want to write it down as the square root of negative 1. Let's just keep it as I. So this I is I to the 17th power is the same thing as I. And there's my answer. Alright, now for the next operations, we are going to add or subtract complex numbers. So we have a real number and an imaginary. So first let's look at adding. We have 2 complex numbers, 4 plus 2i, that's one of them. Negative 6 minus 7i, that's the next one. In the middle, you see the plus sign, so that means you are adding. When you add complex numbers, all you do, you bring down what's inside of the parentheses. 4 plus 2i. Even though this is a plus, don't use it. Just bring down the complex number in the second parentheses. So there's the negative 6i, it's negative 6, so negative 6 here, minus 7i. You're going to combine like terms. Complex numbers always have the real number first. So I'm looking at the real number here. The 4 does not have an I. Negative 6 does not have an I. So you combine those two. That's negative 2. And you combine the imaginary numbers, or pure imaginary. 2i minus 7i. That's negative 5i. So this is how you add complex numbers. There is my answer. When you subtract, it's a little bit different because you do have to do something with a negative here in the middle. Every time you have a negative, first you distribute this negative to the second parenthesis. The first parenthesis doesn't have anything outside, so I'm just going to bring it down. I'm just going to copy the complex number. I'm going to distribute, I'm going to multiply, so negative times negative, that's positive 2. Negative times negative again, that's positive 3i. You're going to start combining the real numbers. So there's the 5, the 2, so that's positive 7, negative 2i, positive 3i, that's plus 1i. We don't need the 1 in front of the I, just I. So here's my answer. For example 3, we are going to multiply. So we're doing some operations, adding, subtracting, multiplying. Multiplication, there's one value that you really have to remember, and you guys will see which one I'm talking about. But first, let's look at the number outside the pure imaginary, outside the parentheses. You distribute and distribute. So first, negative 2i times 2, you multiply the coefficients, the numbers. So it's negative 4. Keep the I. This 2 doesn't have an I, so just keep the I that's outside. When you multiply the next one, first, negative times negative, you look at the signs, that's going to be positive. Multiply the numbers, 2 times 4 is 8. And I times I, they're the same variable, so it's going to be I squared. This one has an imaginary 1 exponent, this one has an imaginary 1, so you add the exponents. The value that you really have to remember is one of them from the 4 values I give you at the beginning, is this one, I squared, is negative 1. So every time you have an I squared, you are going to substitute a negative 1. So we do have an I squared here. So negative 4i, you bring it down, plus 8, substitute a negative 1, and you simplify. So negative 4i minus 8, you multiply, you distribute. Complex numbers always have the real number first, so I'm just going to switch the order. There's the negative 8 and the minus 4i. So there's the answer. Here we have two complex numbers, so we do have two parentheses. We are multiplying, there's nothing in the middle of the parentheses, so that means multiplication. I like to use the FOIL method to distribute or multiply. So I'm going to use that method, well, you can say method. You multiply the front, so 4 times 3 or 3 times 4, that's 12. Multiply the outer, 3 times negative I, that's minus 3i. Multiply the inner, that's 24 positive 24i. And last, so that's positive times negative is negative. 6i times I is going to be I squared. You are able to combine these two terms. They are like terms, they're pure imaginary. And remember, I squared is negative 1, so you're going to substitute a negative 1. So you bring down the 12, doesn't have a like term. Combine the i's, so that's plus 21i minus 6, substitute a negative 1, distribute this part here. So that's a 12 plus 21i plus 6. We do have like terms with the real numbers, 12 and 6. So that's going to be 18 plus 21i. So here's my answer. Alright, I think this is the last example for today. We are multiplying and we do have two pure imaginary numbers. So it's the same idea. There's nothing in the middle of the parentheses. There's no plus, there's no minus. So that means you're multiplying. You're just going to multiply. First, multiply the numbers, coefficients. So negative 5 times 6, that's negative 30. You multiply the i's. So I times I, that's I squared. Remember, I squared equals negative 1. So you substitute. So there's the negative 30. Substitute a negative 1. Multiply again. So that's positive 30. And so there's the answer. Over here, same thing. Multiply the numbers. 2 times negative 6, that's negative 12. I times I, that's I squared. Substitute a negative 1 because we do have an I squared. And multiply the numbers. So that's going to be positive 12. You can have a negative answer, you can have a positive answer. But that's how you multiply pure imaginary numbers. Alright guys, and I'll see you next time.